Hello everyone! Today we will talk about database migrations in Java using Liquibase as an example. Liquibase is one of the most popular tools for managing changes in databases. I certainly don't promise that this video won't have any fluff, but I will try. Surely when you hear the word migration, the first thing that comes to mind is either the migration of wild animals or migration to another country. But as you understand, today we will not be talking about that at all. Database migration is a process that allows you to manage changes in the structure of your database. For example, adding new tables, modifying existing columns, or deleting unnecessary data. Why is this so important? In modern projects, especially when a team of developers is working on a single project, in parallel branches, it is important to synchronize the database with the application code. This process is often compared to Git, where we have commits, and here we have changes sets. And this is where Liquibase comes to our aid, as you can track the history of changes, or rather the versions of your database, through the structure of the files. Migration facilitates automation, helps avoid human errors, although they will still occur, as we are human, and allows for tracking changes in the database using a version control system. And before we move on to Liquibase, let's take a look at our project, which we will be working on today. Currently, it consists of only two entities, company and employees. I think that will be enough for us today just to understand the principle of how Liquibase works. What dependencies do we need? For this, we take the form file. We need to add H2 as we will be working with an example of the H2 database, specifically Liquibase and Spring Boot Starter Data JPA. You will understand what each is for later. The final link to the guide will be in the description. So, let's open application.yaml. This is our Spring Boot configuration file. Here, we specify our database. For now, we have Liquibase turned off. We only have JPA. What can JPA currently rely on? Let's take a look at our classes. Class company. You see, we use Lombok so that we don't have to use setters and getters and write them separately. We simply use annotations. We also have the entity annotation which relates to JPA. ID can also be classified in that context. So what is JPA? JPA is the Java Persistence API. It is a Java specification for managing the persistence of data in applications. But what kind of creature is this? JPA allows developers to work with databases through object relational mapping, or ORM, where Java objects are mapped to records in data tables. What else do we have here that is interesting? What else do our classes consist of? We have a company ID column, a name column, and a one-to-many relationship. This means that one company can have many employees. We have employees, which is essentially the tables of employees. We have a column for employee ID, a column for name, and a many-to-one relationship, as one company can have many employees. We have a private company. In fact, if we run our project now, we will see that two corresponding tables, company and employees, are created in the database. For this, we just need to change a few settings. We will simply run it now, and there will be nothing there. Let's start the application. That's it, our application has started. To see what we have with the database, we have specified that we are using H2 and the console is enabled. Why am I using this console? This is for the convenience of working directly with this database. If you have IntelliJ IDEA Ultimate, you can connect it to databases directly within the application. But let's say you don't have it, there is universal access through your browser. For this, we go to the browser. We access the address localhost 8080 H2 console. Since the application is running, we have access to our database. Let's check what we have inside now. We see that we don't have any tables. Good. Let's return to our application. Here is our connection to the database. This is the data source URL. The URL of our database. H2 is an in-memory database. It is very lightweight and convenient to work with for some test projects. Quick connection, and it's stored in your memory. I save it in a file. The username and password are something you create for yourself, nothing complicated. What do we need to change? We used annotations from JPA, which could automatically create tables based on our entities. That is, we have locked that, we will have table employee, but as you just saw, it is not in the database yet. To make them appear, we simply add them in application.yaml.tl.after. This describes the schema, as you will introduce yourself during the application startup. If we change it to create and restart, it will read all our classes that have the table annotation and create the necessary table in the database. The ghost has started. Let's open our database and refresh. Voila, we have companies and employees. The seasons are still empty. We haven't added anything to them, but it works. However, today we will leave it inactive. Let's go back to none, as we only need annotations from GPIO. We will return our database to its original state by simply deleting this DB file. Now let's move on to Liquibase. Liquibase is an open source tool that allows you to describe changes in the database in XML, YAML, JSON, or SQL formats. Personally, I really love this because we can describe the files that create the tables. Let's say I love XML, while the files for populating our database with some test data can be written in SQL format. It's up to you. Some prefer to write their creation and filling entirely in SQL, while others combine approaches. So choose whatever is more convenient for you. What is the main advantage of Liquibase? It is the ability to control all changes using a version control system. What does Liquibase consist of? For this, we can open their official website. Here, let's say we open SQL. So this is how Liquibase works. Now, this is our file. In this case, it is SQL, but as I mentioned, it can also be YAML, XML, or even JSON. These files are part of the change set. Then the change set goes into the change log. Only Liquibase itself enters the change log, which in turn sends the changes to the database. In fact, this SQL migration change set, changelog, Liquibase database is essentially what migration is. Let's take a closer look at what each of these change set and changelog means. Liquibase uses changelog files. This is a kind of changelog where you describe all the operations that need to be performed on the database. Then Liquibase compares the current state of the database with the changelog and applies only those changes that have not yet been executed. So, let's take a look at the settings that need to be made. In Java, in the application.yaml file. As I mentioned earlier, we need to enable our Liquibase, enable true. Now we need to specify where this main changelog file will actually be located. I will prepare all the templates. The changelog will be located at db changelog changes changelog master, XML. We have prepared the db. Let's look at the master changelog. We will also add a directory called changes to it, where we can now comfortably place the master changelog file. Let's see what is inside this file. Changelog master is the instruction that Liquibase will use to build your database. The order is important because it will process from top to bottom. For example, in our case, we have a company and we have an employee. If we try to create and populate the employee first, but we do not yet have a database with companies, and we attempt to assign the company ID to the employee that does not exist yet, we will certainly encounter an error. Therefore, it is very important to establish the correct order of operations with your database. For now, we can remove this. You see two files. This is version 0.0.1. Next, we specify our file, its name. It would be good to know when this file was created, that is, the date. A number for conveniently organizing the sequence. And actually, what it does inside. If we go into our file. To do this, we present our db changelog. Here is our version 0.0.1. Here is our create. This is a standard XML file. It lacks the standard header that you can find again on the Liquibase website. I strongly recommend that you read the documentation. It will be very useful for you in the future and will often be necessary, because even ChatGPT may not help you, as it has its own data update cycle. While the information on the website is always the most current. We have the header and our change set. This is the block. The change set. What does it consist of? The first is the author and the ID. The author, of course, is yourself. The ID depends on how your team operates. Here, there could actually be some ID-like number like 1, 2, 3, 4, 5. In my case, it is just a description of what the table does. This condition is checked before creating the table. Before creating it, it checks. And if such a table already exists, it will issue a message that the table already exists. Next, we went through the conditions before execution. Then, we proceeded to the actual creation of the table. Creating a table named companies, a column where the table is located. The column company ID, type binary 16, I use UID, this is the primary key, it cannot be null. The second column is name varchar, which means it's a text column. And again, it cannot be null. Everything is quite simple. In fact, the table with employees is created in the same way for the team. Standard header. Again, the author ID is unique. Again, the same condition is applied before the script runs. Next, we create the table for employees. The same column for employee ID is included, as well as the name. The only addition here is another column, which represents the connection between the employee and the company. This means that each employee will correspond to a company ID, indicating the company they work for. We have a foreign key called foreignkey.companyid, which will be taken from the company's table. It is referred to as companyid there. So we have two files that need to run when our Spring application starts. We have activated Liquibase. We don't have a database. We deleted it. Let's try to run our project. Everything started up. Great, and we can look in the blogs to see how Liquibase works. So, the change set ran, the first create company, it executed, A snapshot of the database was created. The company's table was created with a report that the command was successfully, efficiently, and thoroughly completed. Next, the second. Employee was created and the change set executed successfully. Now let's check what has happened in the database itself. Let's go back to our H2 database. We slightly update it. We see that we have actually created company and employees. They are currently empty. But you can also see that when Liquibase is run, 2 new tables have been added. Database changelog. This is service information. And in fact, you will see the same information in it. Just like here. As I mentioned earlier, we can not only create tables but also modify them. I have prepared a file called change. What does it do? Header standard, change set. Again, author ID with description. But this time we will use the rename column. That is, I will rename the column in the employees table, changing the old name to the full name. In order for this script to work, we need to add it to our changelog master. We simply copy it. We deliver to you. And now let's check what we actually had in the employee before, the name column. Here, we see the name column. We start the project. The project has now started. We see that only 1 run has been executed so far. 2 had already been processed before him, and there were no changes in them. A total of 3 sets were read. Now we see that the database itself has changed. We are updating. We look at our employee table and see that we now have a full name column. Thus, you can make the necessary changes. And anyone who will work with you in the team or on the project will always see these versions of changes and additions related to your database. But we don't need this change for now. We will remove it from our change block master. Let's build the project. We will roughly clean our database by simply deleting these 2 files. You can also populate our test database. Again, you can use any file format such as XML, SQL, JSON, or anything else for this. I like using SQL. For this, I prepared a file for adding data. Again, for accessing Liquibase, we have the author, a colon, and an ID. What do we need to do? We need to add the company table, which has only 2 columns. ID and name. The value is the ID and name. Insert into employees. Again, it has 3 columns. ID, the same ID in order to maintain the integrity of the database. If we now add this file, and we will run our application. 3 files have been processed. Everything is great. Updating the database. Could I really have forgotten the password that corresponds to 2 characters? Let's look at our companies. We actually have a company called First. If we check what we have in place, here are our first and second. As we mentioned, we have the company first and in place, first and second. Everything is working. So, we have discussed what database migration is, why it is needed, how Liquibase works, and how to set it up. In a Java project, Liquibase is a powerful tool that significantly simplifies management. Database changes, especially in large teams and projects. If you have any questions on the topic, please leave comments. We will all read and take into account in the following videos, so thank you for watching. We look forward to seeing you next time.